momentarily. Please stand by. Good morning and welcome to the fifth and final session of the A320 programming class. As I said before, this class may run slightly over the hour-and-a-half mark. I'm kind of anticipating 2 hours for this class. Han has to get through the program format. So this is going to be the culmination, basically, of the last 2 days of putting everything we've learned into an actual program. So this program is the ejector. So you know the ejector tip that is inside your machine, L20 or A20, the part that's going to screw on the ejector rod. This is the tip that is made in this class for that part. So at the end of this, everybody's going to have a usable program that will make that ejector tip. So Han is going to do 2 different ways of doing the same thing just for demonstration purposes. I know we've covered a lot of information in the last couple of days. If you've attended the classes here at our facility, normally there are 4 days, and we've covered many of the same material in a much less time. So this is definitely a much more condensed class than is normally given here at our facility for time purposes. We actually have learned quite a bit from this first 5 sessions, and hope to reproduce this training again in a very near future. Keep your eye out for new offerings, including other machine applications training and setup and other instructional videos as we continue to improve our support to customers, via video library and online support. And considering we've all gone through the last 10, 12 weeks, we're adapting and coming up with new ways to make things better and to get information out and share and spread information. So at this time, I'm going to go ahead and turn it over to Mr. Han Phan and enjoy session 5. Go ahead, Han.
All right, good morning, everybody. Welcome back to session 5 for the programming class for the A320. Yesterday, we have a question from, I believe it's Brian, about the Q argument, and then we do a little bit research, and then hopefully this answer can satisfy your questions. So the letter Q argument that you're using in the M98 is basically right here, and is a sequence number inside the subprogram. And as you can see down here, if you're gonna use M98 right here, so if you're gonna use M98 right here, and then you call the subprogram with the P, and then you're gonna have the Q argument right here. Basically, the Q is gonna go inside the subprogram. As you can see, the main program command right here, M98 P with the program number and the Q value. And so it's going to the subprogram, which is 1010. It is right here, 01010. And then the Q is said looking for the block number is 1030. So it's gonna jump into subprogram and jump right into this one and skip whatever ahead of it, and then just run until it's hit M99, and then it's gonna come back to the main spindle. So it is like subprogram call for the sequence number. And then again, you was correct that you need to change the parameter 6005 from 0 to 1, and then you can do it. If you don't change it 0 to 1, you cannot do it. I hope that answer your questions. All right, we're gonna go back to the project today. Since we already learned about the MC data, and then next thing we're gonna know is about, we already learned also about G600 code, and then I explained a little bit about M and G code. So M and G code, most of the time you need to spend your own time in order to understand it completely, because the time frame we have here is not enough. So we sorry about that. Maybe in the future we can extend the class so we can have more deep explanation. But right now we don't have that kind of like advantage. So this is the part that we already talked about in the first day already. And then I'm gonna go into the OneNote in order to, all right, let me stop sharing this. And then I'll share OneNote. All right, everybody can see my OneNote, right? Mr. Richard, you can see my OneNote.
Han, your notes are visible.
Okay,
Yeah,
thank
sorry,
you.
I can see it, Han. I'm sorry, my unmute wouldn't work.
Okay, all right. So yesterday we talked about, okay, we're gonna have two way for this class in order to make this part. So the first way is gonna be G630, and the other way is gonna be G660. We're gonna go over this one really quick. So we have $1 right here, $2 right here. Same thing on this side, $1, $2. Okay, so we all agree we're gonna have tool number 2 for facing. So tool 2 facing. And then we're gonna have a spot reel on 11. Spot reel. Okay, so spot reel right here, as we can see, look at the part, and then we can see the hole right in the middle. The size is 166. So the spot reel right here, we can use 187. It should be enough. It's gonna give you a little bit chamfer on the ID. So 187, I think it should be enough. And then the tool 12, we're gonna use the 166 drill. Okay, and after that, we're gonna use the tool number 2 again in order to do OD turn. And then after that, we're gonna use the milling, which is the tool number 7. And in this case, if you can calculate it, and then you can see the milling section right there, the width is only about 150 something. So right here, we can use a 1/4 inch end mill. It should be okay. And we can use square end mill. And then, as we already discussed like a couple days ago, we're gonna do a little bit back turn in order to get rid of a little material, so we can leave less for the back spine to do. So we're gonna use the tool number 3, back turn. And after that, on the other side 1, we will complete with the tool number 1 for the cutout. Okay, so $sign 2 right here, as we're gonna use G630, so we're gonna have the tool number 31, left hand boring bar. And then we can have the tool number 32 for spot reel. Again, we're gonna use 1/807 spot reel. And then again, same thing, tool number 33 is going to be 166 drill. And last, we're going to do threading. So it's going to be tool number 34, OD thread. Okay, and then that's done. We're going to do ejection right here. And that should complete the program for G630. And same thing over here, G660, we're gonna copy the whole thing over here and then just move it over here on $1. So $1, nothing's gonna change because all the tool station will be the same. But in $2 right here, we might change a little bit. Tool number 31, we're still using left hand boring bar. But then now, since we call the tool number 11 right here for spot drill, as you know, in the G660, you need to call the tool parallel. So we have to call T51 for the spot drill. And right here, same thing, we're going to use 1/877 spot drill. Excuse my handwriting, it's not that good. All right. So next thing we're going to do is the tool number 52 for the drill. We have T52 for 166 drill. All right, and the last one, we're going to use the same tool, T34 OD thread. And after that, we're going to eject it. Okay, so after we sketch it out like this, and then we can begin to do the program. So I know a lot of people might be tired of my handwriting, so I will stop using it right now, and then maybe I need to type it out right now. So, all right, let me stop sharing this. I will share my. Okay, where is? All right, right here. Where's your sharing window? It's not sharing it. Alright. What is? Why? I don't know why I cannot sharing my WinCNC, Mr. Richard.
It won't come up.
It won't come up. All right, give me 1 second. Hold on.
Everybody hold on. We are having technical difficulties.
This one up here like this. Okay, so
There
do
we
you
go.
see? Do you see
I
my
s-
screen? Okay.
Yep, I see WinCNC.
Okay, so right here, if anybody use WinCNC, you will know that we have the screen like this.
Hey, Mr. Hahn, if I could interject real quick. If you
Okay.
wouldn't mind just explaining to everybody how to make sure they get $1 and $2, make sure you show them how to select the machine.
Oh, okay. All right, I get to that point. Okay. If anybody using the WinCNC, you will see the screen like this. And then basically what you're gonna do, okay, WinCNC gives you a lot of ability, just like create a basic background for you for the new program. And then what you need to do is you're gonna go to the new is right here at the corner. You hit it. When this wanna come up, you're gonna pick up whatever the machine that you're gonna need to program. So in this case, it's gonna be A320 Type 7 for node control. After you select it, you can hit OK. And then it will ask you, okay, what you want to do with this. So you want to do front and back thrilling cutoff with the G630, or you want to do front and back thrilling cutoff with G660. So you're going to choose whatever you want to do with this, click on it, and then hit OK. So there you go. You're going to have a table right here. It is exactly like the machining data information right there. You're going to fill out, and then something right here is kind of a little bit different, but you don't need to worry about this. You can like adjust it on the machine, but then it can give you some information like the stock diameter, positioning point, machine length, everything like that is right here. And then you just can hit OK. As long as you have it, hit OK, and then now you have a background of the program like this. And then it's also, if you pay attention, you also have the $0 right here, which is for the machining data information also. Okay, some people might be having the problem, to view this. So maybe your WinCNC will show only $1 side one, and then you have to scroll down in order to see $2, but it doesn't show up with two sides like this. What you're gonna do, you go up on the top right here, and then it has a function called parameters. So with parameters right here, you click it. Okay, as you can see, I will do it very quick, like right here, and then you will see what happened. All right. Then let's see, B12. All right, if I select a B12 like this, I hit save, and then you see right now, the WinCNC, instead of have two sides like I had before, but now I have only one side. It really easy. You just go back parameter right here and pick the right machine, and it will come back up two side. So in this case, we're gonna use A320.
If you could pause right there for a second, Han.
Okay.
So I don't know if everybody else sees what I see, but the drop-down menu is totally black. In reality, that page will be filled with machines. So maybe everybody can see this and it's just me, but that drop-down menu where Han's pointer is at is filled with different type of machines. So you would simply scroll to the machine. You can't see that for whatever reason. You would simply scroll to the machine you have and select it, and this will be the result. Go ahead, Mr. Han.
Okay. So basically, I picked the machine A320 Type 7 for no control, and then I hit save, and then there we go. It back up with two screen right now, and then it gives you a basic like information. Okay, how you gonna start at the beginning right here, and it has some like variable. It makes your job it's a little bit easy by just fill out the number right here too, and it has the first thing to start. Remember, we picked the machine with G630, and then here it is G630 right here. And on dollar side 2 is also the same with G630. So it gives you a good easy start right here, and then all you have to do is just fill out all information in here. And the cutoff operation, you also see it also make it right here for you. You can put the length in here and stuff like that. But in this case, we're going to just use like we need to do it from very beginning, so we're not going to use anything like this. Basically, I will clear up everything and we start from scratch. Okay, so right here we're gonna have dollar sign one over here. On this side we're gonna have dollar sign two. Before we start, we're gonna have to give the program a number. So we're gonna start with the letter O, and then the program number, it can go up to 8 digits. So in this case, I want to use maybe, okay, 0001. But you can pick whatever number that you want. And then you're gonna give it a name. So right here, maybe say knockout. All right, and after that, after you're done, maybe I'm gonna zoom it a little bit bigger so you can see it easier. How about that now? Is that good? Everybody see it clear?
Looks real good to me.
All right. So the first thing we're gonna start with the program, we're gonna have something it just call a safety codes. First thing we're gonna start with maybe G813, which is, is used to cancel the sync between the spindle, between the main spindle and sub spindle. The reason why is sometimes if we running the machine and it's in the syncing mode, if you start from the beginning and the machine is still in syncing mode, and sometimes it gives you a weird problem. So uh, G813 right here, it's just a safety code, but it's not like something extra, something not useful. Okay, next thing we're gonna go, maybe we put G99 right here and G40 in order to just like cancel the to cut the com for some reason. If it gets stuck, it can cancel it right here. And then also tell the machine, okay, I want you to go into the rebel rep. I mean the feed rate is gonna be rebel. I'm sorry. Um, inch per revolution. I'm sorry. Okay, so next thing we're gonna do is we will make sure the collet gonna close with M6, and then we want to maybe turn on the colon with M52. A lot of people are gonna use a skip lock right here. I use this too, because sometimes when you do to make the program and it's the first program, you want to run it and you want to prove it, and then you don't want a colon turn on to block your view. So you can put this one, the skip lock. So when you run it, you can have the skip lock function on, and then you can like have the colon not turn on, so you can see what's going on inside the machine. So the next thing I'm gonna do is the very important thing is the G50. So you have to have the G50 right away after the safety codes right here. The reason why we already explained is to tell the machine where is the machine at right now, the position that machine gonna use to calculate for the whole program. So we're gonna put right here G50. In this case, I want to use left hand cutoff. So the left hand cutoff, it will give you the ability to get close to the sub spindle. So in this case, you see we have a long part and we're planning to pick up all the way inside, almost to the shoulder where the milling section is. So I want to use the, if you have the extension no collet, and then it's fine. And then you can use the right hand cutoff to get close to the main spindle. But in this case, just make it easier for everybody. We're gonna just use the regular collet for pickup on the sub spindle. So I'm gonna use the left hand cutoff. So the left hand cutoff um, is gonna be okay. In this case, we maybe the you know that the block uh, the first tool is gonna be 5/8 for that slot. So basically, it's gonna be 625. But again, 625 is the whole thing. So you have to ship uh, over to the one side of the cutoff. So we need to minus for, alright, we need to minus for whatever the width of the cutoff right here, which is in this case, maybe I'm going to use 3 millimeter, which is 118. So another thing is if you gonna start the machine right here, so next thing, if you coming up with the turning tool, you will have no material to face. So another thing what we have to add in here is some material for it to face. And in this case, I will add 5,000 in here. And that's going to be your G50 at the beginning, and we call it the start position. Okay, so after we have the start position, we're going to start the machine, and then I want to turn on the spindle a little bit so we can have M3 S1 and then ship equal maybe 1500. We just started, we started slow, but we're not cutting anything right here, so it's okay. And then one thing I always do right here, I want to move the material out of the way. So I will go G0 X point, so 600. Okay, I forgot to say, remember yesterday we said that we're going to use the stock is going to be 1/2 inch, right? So we're going to say, okay, right here, 1/2 inch material. Okay, so 1/2 inch material, so right here, by moving up 600, it's already above the material. And then I know that I'm safe on the X direction. So same thing, the Z direction, I want to move it back a little bit. So Z minus 50,000 right there. So the machine right here, somebody gonna ask me, okay, if you command like this without calling any G600 mode, will the machine know where to go? So the machine, when it first start, when you turn it on in the morning, it will default, it's gonna be G600. So it knows right away on the light side 1, it will control X1, Y1, Z1, and C1. So right here, if you input X.6, Z minus 50,000, it will know right away, okay, wherever the current tool at, just move it up on the X and Z. On the $1 is just the main spindle. And the next thing we're gonna do, okay, well, as we talked like yesterday, we have a function called tool cut up break detector, and we use a sensor at the tool number 19, and then we're gonna come in order to check to see, okay, actually the material is already retract, or the part is separate from the machine already or not, to make sure, okay, our cutoff is not broken and is safe to start. So I put it right here, the M51. The next thing is we're gonna do, okay, everything is done so far for the safety check and everything already. The material is already moved away. Now we can start with the G630 mode. So with G630 mode is automatically tell machine, hey, now I'm going to simultaneously machining mode. So just ready for whatever you need to do. So right now, the $1 it will automatically know all the tool that it can call. That means from the tool 1 to tool 9 and tool 11 to tool 14 is only those tools can be commanded in order to run on $1. And same thing on $2, the tool from 31 to 34 is gonna be the tool will be available to call. So right now, we're gonna do first thing first, we're gonna call the tool. We're gonna have T0200. All right, what we're gonna do, we're gonna need to give the operator and set up some kind like okay, visual about what tool we're gonna use right here. Okay, the tool we're gonna use right here, since you can see we just turn the OD and we just do the facing only. So we're not gonna do anything that profiling or undercut. So we can use 80-degree insert right there, and then you will give the operator and set up more detail. Okay, we're gonna use 8,000 corner radius tool in a to turn. So 8,000 corner radius right here. And then, okay, maybe another information, one more information, it will not hurt at all, but it will, um, give the operator and set up more detail. Okay, let's say put 4 in P column into data set. So that means we're going to use the OD turning tool and the tip direction is going to be number 4. So the operator can read this and then put it right away in there with the radius 8,000 and then the direction is going to be 4 because we're going to use the tool node radius compensate later on. So after that, we're going to do is we're going to have to call the machine rotation. So I would like to use the constant surface finish. So right here, we're gonna do G96 and then S. So the material we're gonna do right here, maybe we're gonna go back here and say, okay, material we're gonna use brass. So brass is had a constant surface finish is about 800 to 1500 according to the information I get from the internet for feet and speed. You can look it up online. And then, okay, in this case, maybe I can use like 900. I don't want to go too aggressive for, the first time. But then, if you use constant surface finish right here, you need to give it a limit. Because if you don't give it a limit, as soon as the tool go close to a center and past center, the RPM is going to go to infinity. So right here, we can give it G50 S, maybe, 400 right here, RPM. Okay. And then what next thing we can do is, oops, all right, all right. Next thing we can do is we can call it into the position, okay? So we can put G0 x 0.6 and Z minus 50,000. And then also right here, we can turn on the offset right here. So as you pay attention right here, I always call the tool with no offset. And the reason why is some tool like more than the tool number 31, we cannot call the offset together with calling the tool, which is if you're gonna command right here T3131, the machine, it will not allow you to do this. So that way I want to keep everything simple, everything is the same format. So I will call the tool without the offset right here. And the offset I will put at right here at the first line that I'm positioning the tool. Let's see, we have some questions here or what? Do we have questions here?
Yes,
Yeah,
we have to use spindle fluctuation cancel when we use G96.
Okay, yes.
I just don't think Han's quite to that point yet.
No,
He's
no.
going to talk about that right now.
No, not yet. So you got a little bit jump ahead of me. Okay, I'll get to that point right now. All right. So first thing, we set it with the constant surface finish. We set it with the limit right here. We go to this point, and then we remember we talked yesterday the spindle reflection. I'm sorry. Turning on and off. We need to do it with the constant surface finish. So we need to put it right here. And then you remember that on $1, which is the main spindle, we're going to use M97 in order to turn off the spindle fluctuation. We still have questions? Can you explain how to get the number on the 6th slide, the code again? The line 6, 7, okay.
Are they talking about the G50, I think?
7, okay. The G50, right? Maybe see if I can draw it here.
Yes, that's it.
Okay. So, all right, I need to get back to here. Let me stop sharing this. I'm gonna share my OneNote. Okay, reason. Okay, stop sharing it. Share. All right. You guys can see my OneNote page right now.
Yes.
Okay. So very simple like this. We have the main spindle with the guy pushing like this, and it's carrying the material. And then in this case, I said we're gonna use the left hand cutout. Right. So this side of the cutout is gonna be Z0. And then now we have the material is sticking out like this right here. It's sticking out this much right here. Okay, so the first thing we need to know, okay, where is this position right here? So we have some information in order to calculate it, which is the width of the tool right here. In this case, the pocket for this tool, the pocket number 1 is going to be 5/8. So 5/8, you know, is 625. But then 625, that means you're going to be this point right here. And then I said I'm going to using the cut up insert with the width is going to be 118. That means to move from this point to over here, I have to minus for the width of the cut off. That's why I come up with minus 118. And then if you're going to start right here, that means this face right here is right on the edge of the tip of the tool right here on the right side. That means if you calling the next tool, the main spindle, it will know that it retract back in order to make the 0 right here for the next tool to turn. But then you will not have anything to face. So I will put another minus 5,000 right here. And it's just because I want to leave some material for the turning tool come back to face it. So does it make sense? So I hope I answer your questions and you can understand now. Okay, good. All right. So now we're gonna go back to the other screen. Okay. Okay, you see my WinCNC screen again already, right?
Yes.
All right, good. So we're gonna continuing, okay? So right here, after we
Correct me if
call
I'm
it
wrong, but I know 100% of the Mitsubishi.
what?
I'm sorry, Han, go ahead.
Okay. So we set it G96 right here for constant surface finish. We set a limit for it to turn, and then we also remember, okay, turn on the fluctuation off. I mean, turn off the fluctuation so the machine it will not give you alarm. So, and then right here, we positioning the tool at 600 and then negative 50,000. That means we know that the tool is start above the material and then the material is already retract. So it's clear. And then we also call the offset right here. So next thing we can do, all right, since we're gonna facing the material, so I will jump right into Z0 because I don't want to, wasting more time to cutting air. So right here, we jumping into it. The next thing we can start cutting by G1, and then one more is not like something extra, G99, that tell the machine, okay, I want you to calculate in inches per revolution. So right here, and then we can turn on the tool node compensate also. Since we're gonna cut on the right side of the material, so we have G42, and then we can tell the machine, okay, I want you to cut down to X minus 50,000. Since we're using the 8,000 radius only, that means if we go past the center, 25,000 is already enough to clear the face. And then we put it right here, the feed rate. Since it's like press, so I can go a little bit fast with 3,000 inches per revolution. And then after I done, I will move it out 20,000. Make sure, okay, before I escape the tool, I will not leave any mark on the face of the part. And then after that, I can cancel the tool right. I can move it out to on the top, and then I cancel the tool right here. So that means we finished the operation for the first thing, and then maybe we can put right here a note is just facing. And after that, don't forget to turn on the fluctuation again, which is M96. And then you don't forget to put G97 back on. Okay, if you don't turn on the constant surface finish, the next tool, the constant surface finish, it will activate it. And doesn't matter how fast you're gonna command it, it will calculate it like based on the diameter where's the tip of the tool gonna be. So we have a questions here. What is this? Oh yeah, okay. Z minus 20,000. I'm sorry. I so get used to I was working with the piano, so thank you for correcting that. All right, so the next thing, we finish this tour, we can jump to the next tour, and then we're still in the G630 mode, and then we don't need to change the mode in order to call the next tour, which is the tour number 11. So number 11, we can have T1100, and then again, I'm not gonna call the tour with the offset, and we may give it right here spot thrill. All right, and then give more information right here is 0.8700 right here spot thrill. Maybe in diameter spot. How about that? Okay, so the way I do the programming, I want to give as much information as possible for the operator or setup guys so they can look at it and they're not gonna get confusing. So right here, we're not gonna use tool no compensate for the spot reel, so I think that enough information right there. And then we're gonna call on, okay, the spindle. S1 equal. Alright, you can turn on whatever you want right here based on the material and the tool you're using. I just put in there 2500 just for now. And then we can call G0. So this is a spot rail, so I want to call it right into the center. And then also away from the face of the tool, face of the part, 50,000. Same thing, we're gonna call the offset on this line. Alright, and then we can start cutting right here with G1, G99, and then Z. Okay, so right here we wanted to make a little bit calculation. So the hole is going to be 166. So the hole is 166. We want to put the chamfer maybe 10,000. So 10,000 on the Z, that means we're gonna have 20,000 on the X. That means the finished diameter we're gonna have is 186. And 186 in diameter, that means for the spot rail 90-degree, we're gonna have the Z move by half of the diameter, which is we're gonna have 186 divided by 2 is gonna be 93,000. So we're gonna put in here 93,000 we're moving in on the Z in order to make 186 diameter on the X. And then we give it a feed rate right here about 1,000 and a half. We have a questions here.
Yeah, please explain why you don't want to put the tool 11 offset on the tool call.
I think I explained it already, but I'm gonna go over it again. So for the tool call, some tool it will allow you to call the tool with the offset together. But whenever you use the tool from tool 31, like up to 50 something, the machine will not give you the ability to call that. So for example, if you call the tool 5151, that means you call the tool with the offset together right away, the machine it will alarm out. So I just want to keep everything in the same format. That way we can get rid of the alarm. So I always call the tool without the offset. So in this case, we will worry free about the like what tool we need to call with the offset and what tool we are allowed to call with the offset or not. So I always call like that, and then whenever I positioning the tool, I will call the offset right here. the machine, it will work the same way. It will call the offset, read the offset and geometry all together in here. So I hope I explained your questions. All right, moving on. So we have the tool right here as we drill into the part. I mean, we do a spot into the part after we done, because since it's a spot drill, so I want to put a dwell time in here, maybe half a second, in order to let the spot drill make a complete circle and have a good like some finish right there. So we can come in with the drill and no problem. And then after that, we just like rapid it out. See, minus 15 down. And then when we rapid it out, we can do the tool cancel right here, offset cancel right here. And then that's done for this like tool. We can jump to the next tool, which is we agree is going to use is the tool number 12. It is a drill. So drilling cycle is going to be right here. And then give a little bit more information what side of the drill we're using right here. Okay, same thing drilling, we're not going to use tool nodes compensate, so we we have enough information right here. And then we need to call on
On, so we
window.
have I received another question. So
Yes.
should we use G18 and G40 on the tool call? So my opinion of that is yes, as a default fact of programming, G18 and G40 is a great habit to get into. You know, so G18 is plain select, G40 is cutter compensation cancel. So it is a great default
So
default way of in each tool call. That way,
right.
there everything's we know we're back in the same plane.
So we can add it on every single tool if you want, but the default is gonna be G18 at the beginning. But then if you want, you can add it right here on the safety block, right here, G18. And then as long as if we don't go into like milling using the live tooling, or we have to change the plan or anything like that, we don't need to put much in here. It's okay to put the information in here, but it's not required. So we can call, okay, going further, we can put the spindle rotation is right here. And then you can put wherever the spindle rotation right here if you want to. And you calculate it, okay? And then the next thing, the same way with the spot drill, we're gonna call the tool to the center. So I'm gonna call the tool right away at the center and the 50,000 away from the face of the part. And then don't forget to call your offset. With the drill length, we're gonna drill, okay, the part length is 2 inches and 47,000. So we can want to drill it more than halfway. So in this case, we will using the G83, which is a packing drilling cycle. And with the packing drilling cycle, you need to give it the like end position for the z-axis. In this case, I want to go maybe 100, 1 inch and 350. Okay, and next thing we need to tell the machine in the drilling can cycle is the Q. The Q is for packing amount that you want to use. So in this case, you have 166 diameter drill. So if the material is tough, I can go by half, I mean 1/3 of the diameter. That is usually I go 1/3 of the diameter of the drill. But in this case, it's brass, so I can go, half of the drill diameter is still be okay. So in this case, I will go 93,000. This is half of the drill. Or you want, you can make it 100,000, just round it up. It's brass, so it's not gonna hurt that much. And then feed rate, I'll put right here, maybe, all right, 1,500 for inches for revolution. We have a questions here. No, no.
No, I think we're okay. No questions.
All right. So after we're done with this one, but remember yesterday we have another argument is the letter R. So the letter R, it will tell the machine, okay, from wherever the position that you at, I want you to jump right in with whatever amount. So maybe right here we can jump in like 30,000. That means, okay, it tells the machine, I don't want you to start packing at 50,000 away from the part. It wastes up the time. So I want you to jump over 30,000 and start packing from there. And then it's also create the retract plan right there for you. So every time it's retract, it's going to retract out at 30,000, right? At 20,000 is right there. So the R value right here, you can either have as positive or negative number. It doesn't matter. The machine, it will knows like what direction it will go in. We have a questions here. Or no, okay. All right. So that's good that we finished the packing drilling cycle. So it's a good habit to cancel the can cycle after you use it. If you don't put it right here, the machine's still running, but I want to practice a good habit. I always put G800 right here and it's cancel any G80s can cycle that I use. And then after that,
Han,
yes.
so just real quick, do we have a question
Uh-huh.
from Scott? Do we need to use Q1000 or Q0.1?
Okay, so for the Mitsubishi, you can use the decimal point, but then for Nuke control, you have to command it this way. So 10000, that means 100,000 is equal like this. Okay, so if for Nuke control, yes, you have to command it this way. If you command it this way, it will not work. Okay, so moving on. After we cancel the G880 cycle, we will like retract the tool out, and then at the same time we will cancel the offset. That's it. We're done with drilling right here. Next thing we want to do, we can do is we can, start working on the OD, which is we already know we're going to use the tool number 2. So we're going to comment right here, OD turn. So OD turn, same thing. We're going to use the tool no common says, so we better to get the operator setup guide more detail. So I'm going to use 80-degree insert with 8,000. Oh no, 8,000, not 8,000. Okay. Corner radius. And then also we're going to put 4 in P column in tool data. Okay, so that way we minimize anything that's gonna go wrong. And then after that we can start like calling like the spindle rotation. And then also the same thing I want to control with the constant surface finish And in this case, we already know we need to turn off the spindle fluctuation. So M7097 and then G96, no, I mean G50, 4500, no, S 4500, and then G96, S, like I said, we can use like 900 for brass. Okay, and after that we can positioning the tool, which is I can go into X right there minus 50,000, and also call the offset right there. So nothing complain about this because we already go over this. So we're gonna start cutting it, but then remember the material right in the middle we already drill out, so we don't want to start and wasting time cutting. So right here we can start at X 150. That means it's already, good, have enough material right there in order to cut. And then also I want to move in to, okay, minus 20,000. So I get close to the face where I want to cut. And then right here, I can turn on G99, G41, and then Z0 with the feed rate. So right here, I can start facing, turning, go to the face, and then I also turn the tunnel compensate on. So since right now, I'm gonna cut on the left side of the material, so I'm using G41. And then, okay, the part OD is gonna be 315. So we need to decide like we're gonna put a radius in at the corner or not. If not, then we can just like go straight to x-axis. But then, okay, maybe it's gonna be a little bit ugly, so we decide to make a radius in there. So in this case, I want to make like maybe 10,000 radius. So you need to calculate this, and then I hope everybody can calculate it already. Since your position is a programmer, you need to know how to calculate it. So I'm going to move to X position. So I set 10,000 on the X, on the radius. That means I have to put like 20,000 on the X. So I have to move to position is 215 right there. And then I will make a radius with, and then Z minus, no, not minus, it's gonna be 10,000. So right here you put 10,000, or somebody gonna do is gonna use incremental, but then incremental you have to do it like this. Okay, and then give it a radius right here, it's gonna be 10,000. So the radius usually I'm gonna feed it slower, so it's gonna make a nicer like finish. And then after that, we can do is we can turn all the way to the end, all the way to the shoulder right here. It said 590. You guys have the print in front of you, right? So you can follow what I'm doing right here. So Z is gonna be, okay, 2 in something is gonna minus for 500. So Cincom machine you can do like this, 2.0472, and then you can minus for whatever the distance it requires, 5905. So 5905. You can do like this, so you don't have to calculate, or you can just turn on your calculator and then put in there 2 inch. Okay, I'm calculating right now. 2.042 minus 0.5905. It become 1.4567. So you can put like this, the machine, it will know and understand what you're doing, or you can put just a hard number in here, 4, 5, 6, 7. And then I go back to the feed rate. I want to feed it fast. Okay, after that, okay, right here, you can put a chamfer on the part. So the chamfer right here doesn't say anything, so I would like to put like 45 degree in here. And the diameter right here is 3936. So to put 3936 diameter in there, all right, one thing I'm missing right here is G1. Okay, to put G right there, you're gonna need 3936. And then to make the angle is 45 degree. Right, hold on one second. So to make 45 degree, you're gonna calculate from this right here, 3936, you're gonna minus for, all right, 3936 minus for 315 is equal 78 and 610. Moving on the x direction, that means to moving on the z direction, you're going to divide by 2, which is 39.3. So right here, I don't want to calculate for the z direction. All I need to do is do incremental 39.3. And same thing, I want to slow down feed rate a little bit to make it good right here. And then after that, I can move with the z-axis over a little bit. So distance right here is 100 something, so I can do, okay, maybe I can do W 200 with the feed rate turn on, back on to 1.5. Okay, so right here that I know that I'm gonna do, I'm gonna have to mill 2 flat right there. So then I will stop it right there and then turn it all up on the way to, the finished diameter, which is the material OD. And then put in there the W, maybe 20,000. Okay, and then after that, right? Like I said, if you, in some cases, if you want to pull back the material and then you need to put some chamfer on your material. So right here, I put some chamfer in there and then I make sure it go over another 20,000. Right there, okay? And then after that, I'm done with my tool right here. So I will access the tool, but when you access the tool, make sure you're gonna turn up the tool nodes compensate right here, which is I'm gonna go G40 W minus 20,000 right here. And then after that, I can just go out with the tool. So right here, I don't want to retract the material. It doesn't need to, so I just go G0, X up 600,000, and then cancel the tool. And then that's it, we're done for this one right here. And then remember, like I said earlier, whenever you use G96, you have to put it back like G97. And also we have to turn back on the spindle fluctuation too. So M96 and then G97 right here. All right, so next thing we're gonna do is we're gonna mill 2 flat. So mill 2 flat, we're gonna use the live tooling. So live tooling right here, we're gonna call, do we have any questions right here?
We have a question here, T0,
Oh yeah,
so
I'm
canceling.
sorry, T0 to cancel it.
Yeah, oops.
That's what correct, oopsie. All right, So next thing we're gonna do, thank you, Hoan, for that. Next thing we're gonna do is the milling. So milling, we already like agree we're gonna use the tool number 7, and then again, no offset calling right here. So we're gonna say milling 2 flats. All right, and then give the operator some information right here. Uh, quarter inch, square, and mil. Okay, right here. And then you can turn on the spindle. So the live tooling spindle is going to be S3 shift equal. Okay, you can turn on whatever you want. You need to calculate the RPM. Okay. And then I can move to the position, which is X, G0, X 0.6. And then, okay, since I'm gonna doing the flat, so I have to move the cutoff on one side on the y-axis. So if you're gonna calculate it, and you will come up with some number, and then maybe G500, no, 600, it should be enough because the diameter of the part right now is 390 something, and you plus with diameter of the end mill is going to be 250. So it adding up, it should be 6. Okay, let me see. Okay, 0.3936 plus 0.25. So it's 604 something. So if you put in here 650, you probably like save enough to all right, let me pause it right here for a second. All right, sorry everybody. I have a backup right here that we found a mistake that we made, and then we go along with the program already, but nobody uh, found it. Okay, so remember right here, I turned on the tuner compensate, but right here, I didn't turn it up. So that's okay. Right here, we're gonna fix it right away. We have G40. And then W minus 20, like make it 30,000 is right there. Turn it up, compensate, okay? Alrighty, that's it, we fixed it right there. Okay, we're going back to this one right here. But before we going to any further right here, I want to say about the G50 we're gonna put in here. So since we know we're using the live tooling, the center of the live tooling to the face of the guy pushing is going to be 15 millimeter. And then 15 millimeter, if you know is 15, you're going to convert to the inches, it's going to be around 25, it's going to be around 590 and 510. So if you want to have the correct number in your program, and then you're going to shift it. If you don't want it, you said, okay, I'm going to compensate for whatever I have here, and then you don't need to put the G50 in there. So right here, I'm gonna have a G50 W and then minus 0.595 like this right there. That means I'm gonna shift it, the Z0 to the center of the live tooling, which is right here, is the end mill. So one more thing is right here. If we ship it to the center of the end mill, and then we still have to make it up the number in order to, compensate for the side mill weight. So right here, if I don't want to compensate for that in my program, I'm going to shift it one more time, but this time it's going to be W.125. I'm going to shift it back to the side of the end mill. So right here, I'm good, and then I can calculate whatever the number that it's supposed to be. And I can put in here z-axis. Okay, what is the number that we calculated before? All right, let's see the print right here. We have 2.0472 minus 4 0.3937. So 0.3937. We have 1.635. So the Z location right here, I wanted to go a little bit further so I don't have a burr after I finish the milling, and then I do back turn later. So I put in here 1.680. So this way I can be sure that, okay, I have the end mill clean up and then make the flat as good. So right here, you all know that we're gonna using the live tooling. So you will know that we use the G98. But then before that, we're gonna go down to the right diameter of the flat. It's gonna be x.315. And then we're gonna start milling from here, G1, G98, and then Y become minus 0.65. And then the feed rate you can put in here, and then it's going to be inch per minute. Okay, so if you want to put one rough pass and then one finished pass, and then you can do this. You can put this one up like 25. That means you're gonna leave like 20,000, and then down here you can go down to the right diameter, and you can just go back with y 0.65 like that. Okay, so we have one flat right here, and then we need to do the second flat, which is we can turn on, we can flip it over 180 degrees. So one thing right here, we didn't engage with the z-axis, so I can go back here and then input the argument that we command, like we talked about like yesterday already, is the E. So right here, it will index the tool number 7 and also tell the machine to lock the main spindle at 0 degree. So right here, if we have E right here, down here, we just command G0, C 180 degree. But then right here, before I do this, I want to make sure I have my tool away from the material before I rotate it. So that's why I put G0 x.6. That means it moved the tool up and then rotate 180 degrees right here. Then we can move it down x2 x.325, and then G1, and then Y minus 0.65. The feed rate is still activate up here. As long as we don't change the feed rate, we don't need to command the feed rate again. and then go down x 0.315, and then go back to 0.650. And after we're done, we can go G0, X0 right, X6 right there, and then I can cancel the tool after I go back home on Y. So right here, we don't want to pull the material back, so that's why I don't need to call Z to back to home position or anything movement on the Z. So I just cancel the tool right here, tool offset right here. And then don't forget to turn off your wipe tool, which is M80. All right, so next tool we're gonna go over is gonna be the tool number 3, which is the tool number back turn. So T00, let's say back turn right here. Okay, I'm gonna command turn on the spindle, M1 equal maybe 45, whatever that you want to do right here. And then you can, okay, it depends on what back turn that you're gonna use. And sometimes I have to, we have a questions right here. Yes, Mr. Richard, we have questions.
No questions. I just wanted you to pause and ask for any verbal questions.
Okay, so
So we
anybody
do have a statement. So the G50W shifts that were set for the mill have not been canceled.
that's a good catch right there.
Good catch.
All right. Yay, we have a good student right here. All right. Only one people passed for this class. So you know that we have the tool ship right here earlier, to ship to the side of the mill, the end mill. So after we done, remember we have to cancel it. All right, good job, Jerry. W, so we just cancel it for whatever we have here. G50 W 0.5905. Everything back to normal. Okay, good. All right, next thing we're gonna do is the back turn. So usually back turn, I do have a little bit chip over here. For the tool that I use is 3mm. And then after that, I can start like positioning the tool X 0.6 and Z is gonna be, okay, let me call Z tool. All right, 2.0472 minus 0.3937 equal 1.635. So we have 1.635 is a start position for this one right here. And then also tool number 3. Okay, so after that we can plunge down to the diameter that we want, which is right here, the M8, so 8 divided by 25.4 is going to be 3149. So the finished diameter for the threading in the back side is going to be 0.31449. That means we need to leave some material for the back side to clean it up. So I want to go, okay, G1, G99, X point 350. What about that? Feed rate, we can put it right here. All right, 2000 per revolution. And then we can turn it all the way back to Z 2-inch. And then I want to go over a little bit, so I want to go 2.1. Okay, and then right here, one more thing right here If you want to use the tool node compensate, you're gonna use this right here too. So the back turn right here, you can put more detail in. Okay, 188 for the ship, and then maybe you have 4,000 for radius right here. Corner radius. So the back turn, we're gonna use number 3 in P column. In tool data. Right there. Okay, and right here we can turn on the tool node compensate right here, which is G41. All right, and after that, right here, we can go ahead. After we're done with the full length of the part right here, we can go to X.5 W.0, maybe 325. Okay, and then we can turn a little bit over, to make sure that we deburr the face, deburr the top OD, and then after that we can do cancel the compensate. It's going to be U.04 W minus 0.02, and then also we're going to go G0 X to that position, and then we can cancel the tool at 0, and then cancel the ship right here with 118. Alright, so that means we finished for the main spindle. The last thing we're gonna do is just a cut up, but before we're doing a cut up, we need to do on $2 right here. So $2, I will start with tool number 30. That's just my habit. I want to send the sub spindle to original position, and then you can put G0, G50, Z0 right here. You don't need it, it's still okay too. And then also what you're gonna need to do is, remember we use G630, so we're gonna go into G630. And right here, we're gonna call the tool, the first tool to do it is the tool number 31, and it's gonna be left-handed boring bar. Okay, and then also we give the information right here. We're gonna use, okay, so for the back side, we're gonna use the undercut in order to make the thread relief. So let's say right here I'm gonna use 35 degree with the tip is 8,000 corner radius. So in the back side we also turn it with the tool node compensate. So we're gonna use put 4 in P column in tool data right there, and then we're going to turn on the spindle, which is M23 S2 equal 1500, something like that. Okay, we're going to use G96, so we're going to have to turn off the fluctuation for the sub spindle, which is M94. Give it the limits for the spindle, 4,000, and then G96 S 900. Okay, after all of that, we can position the tool. We can put it right here. So the tool, the material in the back side, we already turned it down to what is right, 350. So we can position at 450 and Z minus 50,000, and then turn on tool offset 31. So right here I want to put the chamfer in the back side. The finished OD is going to be 314,000. So we can go to, and we make the chamfer maybe 30,000. So we put it 30,000. So minus is going to be 60,000. 0.349, 14 minus 0.60 is equal to 254. So x 0.254. And then z, I want to get close it a little bit right there. And then right here, I can start using tool nodes compensate z0 with the feed rate 0.001 and a half right there. And then I can go up to and then make a chamfer. Oh, so somebody tell me that okay, we need to start using the comma C or comma R, something like that with the radius. So I'm gonna use it now. So maybe let's leave it this thing right here. Oh, and then also one more thing I forgot, that we need to face the material to length, right? So we put Z0 in here instead, and then we can face this one to X0. But then if we're facing it, and then we have to use G42. Okay, so we're gonna do facing now. Right, so we'll put it right here, facing. And then maybe facing and do the OD at the same time. What about that? Okay, facing and OD turn at the same time. So maybe for facing, you don't need to use a tune up and compensate, but I just use it anyway. And then you're gonna, after you're done, you're gonna retract it out. See, to turn up the tune up compensate, you're gonna G40 right here. W minus 20,000 right there. You turn it up, and then okay, right here, what we can do is we can use the comma C for the chamfer. We have questions here.
The question is, we've never seen a boring bar without a G50.
Okay, yeah. So since I'm using the boring bar right here, and then I don't know like what the distance between the tip of the tool to the center. That's why I just keep it there. You can use it and then put it in the preparation. So if you want, you can put it just right here. G50 W something something.
Use
All right,
something.
no, U something. Okay, and then you can put it right here. But in this case, I don't know what boring bar that you're gonna use, and then the distance, whatever. So maybe you can put in here, or you can put in the preparation. Okay, so next thing we can do is we can move a little bit to the X side right here, G0, X point. We have any more questions right here?
No, just a statement about the shift. I think we're okay.
Okay, so G0X right here, and then you're gonna put something in here. Okay, so the finished diameter is gonna be 314, so we can go to 3200, and then we can start G1, and then G41, and then Z0 with the feed rate like that, and then we can comment like this. 314 comma C 30,000. So with this way, you don't have to calculate the start point and the end point for the chamfer. You can use the comma C, to put whatever the value for the chamfer in here, and then you should be okay. And then the next thing we're gonna go is we're gonna do the Z move. So the part Z move right here, the distance is gonna be 393,710 minus for the gap right here is 59. So we have the finish point is gonna be 3347. So same thing right here on Z, you can put point 3347 and common with the chamfer right here also 3000. Oh no, we're not gonna use this. Right? Yeah, we use it right here. Yep. Okay, we have another common. What is the difference between if you put the C vs the R? Okay, if you put the C right here, that means it's gonna put the chamfer. If you're gonna put the R right here, it's gonna make the radius for you. And that's the only thing that's different. But in this case, we need to make the thread relief, so we want a chamfer. And then the chamfer default, it's gonna be 45 degree. Hope I answer your questions. Okay, so after we go to this point, we have the chamfer, and then we will go to the full depth. 5, it's 5, no, it's 3937. Okay, 3937 right here. And then after that, you're gonna go up right here with the, maybe we can put the radius in here. So the finished diameter is going to be x point 3936. So 3936 with the radius right here. We can put the radius 10,000 right here. Okay, and then we're going to go a little bit over to make sure we compensate for the radius, the tip radius right here, maybe 30,000. And then we're gonna cancel the tunnel radius with G40, the U 0.04, W minus 0.20 right here. And then you can go up GX 100 and then move the tool out of the way. 50 T0 right here. And if you're using the G50, you're gonna put it right here, the value for the U to cancel it. Okay. All right, next thing we're gonna do, we're gonna use T31 to do spot rail. All right, spot rail we're gonna use is 187 diameter spot. Okay, what is the questions? We are picking the message point.
Yeah, you missed a decimal. The decimal point's there. Or did you just put it there?
All right, up here, I missed a decimal point right here. Okay, yes, that's typo. Okay.
And then don't forget M95.
Yes, correct. M95. Sorry. Oh my God, we're gonna run out of time right here. Okay, and G97 also. So the emerald.
So let's pause for a second
Uh-huh.
while you're typing. So I just want to speak for a minute. So as we said, so right now is an hour and a half, and we kind of anticipated that this would run over. I anticipate this to go until 10 o'clock. So hopefully everybody can hang on. I know it's getting, lunchtime for many people back east in the Midwest, but please hold on so we can continue.
Okay, so since the spot drill and the drill is going to be the same operation like the front side, I will just copy it and paste it over here. But then remember to change this one into S2. It's not S1. Okay, and then offset right here also 31. Okay, for the drilling, it's going to be the same thing. I will copy over here and bring it here. Then we're going to say, okay, tool 33, M23, S2, and then tool right here, 32. Okay, so we have, all right, this thing. So it's already done with the drilling, everything right here. So the last tool only we need to do is the tool number 34. Okay, we have a questions right here. What tool number on the left hand boring bar? So the left hand boring bar, oh, yeah, tool 31. Oh my God. Kelly's running out of time right here. So Kelly,
It's okay, Han. Don't rush. Take your time. Do what you got to do.
okay.
Told
Sorry,
everybody it might run over. I figured it would.
okay. Yeah, sorry for typo. All of this thing, okay, because I feel like, okay, we're running out of time right here. I don't want to hold up anybody, but this is really important. We need to go and done this one, so please bear with me. Okay, and M23, we do a threading right here, and then right, 1000. Usually I will thread it 1000, and depend on what type of material you're gonna use a different RPM in here. So, and then you're gonna go G0x.6, Z minus 50,000, and then T34 right here. Okay, and then I'm going to use G76 in order to do the threading cycle right here, and if the half P right here, and how many finish pass that you're going to use, you can put in here that, and right here put 0, 1, that means I'm going to use one finish pass, and then 0, 0, that means I'm going to just like finish it, the thread, and then just come out with 90 degree. Right here, I want to put 29, that means the enter angle for threading is going to be 29 degree. Alright, and the rate, the R right here is the minimum value that you want to leave for a finish. I'm going to put 510 right here, G76 again, and then the finish diameter. The finish diameter is going to be somewhere. Alright, hold on. Let me look it up for the M5. So the finish diameter is going to be 254 610, something like that. Okay, and the Z dimension is going to be, all right, we want to go a little bit past over the thread, but we don't want to go into a shoulder. So we want to say, okay, 390. All right, let me calculate this. 3937 minus 0.059 equal, so 334. But then, okay, you can put it right here, 350. And then we're gonna have argument right here for the P. The P is gonna be the height of the thread, and right here for loop control, it will not accept it, the decimal point. So I will have this one right here. And then the Q is how much you want to do for one pass, for the first pass. I'm going to do is like 9,000 for the first pass. So I put in there 900, Q 900. And then finally it's going to come with the feed rate. So the feed rate I calculated was something like 49.21. All right. So that's it right there. And then after we're done, we're going to go it up to, on the X first. And then we're going to move out on the Z. And then also right here, cancel the tool. All right, so in the back side right here, we already done. The last thing we need to do is the ejector. So ejector, before we going to the M34, we need to stop the sub spindle by M25. And then to make it easy, we're going to use M34 for the ejector can cycle. So that's it. We already done for the main and the sub spindle. And now we're ready in order to go into the cutoff, the pickup operation right here. So if you don't want to cancel G630 right here, you can do it because on the dollar side one, you can still like call the tool number one. But just like a good habit, I will put it right here to make sure, okay, I will cancel everything right here. G600. Have questions? Okay. So G600 and then all dollar sign one, we will call the tool number one. Say something right here, cut up. All right. And then we're gonna say, okay, 3 millimeter, the width of the cut up. So width, insert. All right. And then we're gonna turn on the main spindle, S1 shift equal. So I want to turn it on really slow right here. I don't want to turn it really fast because if you turn on the RPM right here fast, it's gonna take a long time for the machine to catch up in order to synchronize between the dollar sign one, the main spindle and sub spindle. So I put it right here, M3 S1 500, and then in the back spindle, we're gonna turn on the rotation, but in reverse, as we discussed yesterday already, because the sub spindle is in the reverse way. So we want it to run both in the same way. So we have to command it in reverse rotation. Right here, I want to call G814 in order to turn on synchronize between main spindle and sub spindle right here, and then we're gonna have M77 right here. We have questions? Oh no, just comment. Okay, so comment right here, and then we want to move it into the position. So I will have G 0 x.6. That means x.6 is already on top of the material, and then Z right here is the full length of the part. So 2.047 and 6, I think, remember? 2. And then you need to plus with the width of the cutoff, G625. And right here, if you want, you can leave some material for the back side in order to clean it up right here. And then call the offset tool number one. So right here, we want to put some weight code in here. So weight code for 2, L. So we're gonna do the G650 in order to do a pickup. So the weight code right here, it makes sense for me the most. We're gonna put the L650 right here. So we're gonna put it right here, the weighting code. So in dollar side too, we also have to matching it with the waiting code also. So waiting code over here, we're gonna put, all right, ship 1L650 right here. So I see that we have some questions right here. Oh no, just a comment, sorry.
Just
I thought-
comments.
Yeah, I thought you guys have some kind of like questions right here.
Nope, you're doing very well. Keep going.
All right, thank you. So one thing that I said it earlier too, that we need to put um, okay, we need to put the waiting code right here. So somebody, if you don't want to use the G625 right here, you can use G50 right here if you want. So W minus 0.625, because some people might look at this one and then they might don't like understand why you put in there 625. So I myself, I'm gonna do that. I'm gonna put G6 and G50 minus 625 right here. So the operator and then the setup guy can like not confusing at all about this. And then, so remember, before you go into the G650 mode, you need to cancel it. G625 right there. All right, so we have questions.
No questions.
Okay. All right, it keeps showing right here that I have some things going on. So, all right.
So we did get a question. Did you miss $S2 when starting the spindle?
S2, oh yes. All right, good catch. S2 right here. All right, so we have it's right here. Everything is ready. The cutoff in a position, and then our dollar side two is also waiting for it. And then in the back side right here, I'm gonna have is M16, and then we will go to G0. No, we're gonna go into G650 mode in here. All right, G650, G650. All right, and then I will do M16, and then I will move rapid into the front of the material. It's right there. And after that, I'm gonna go a little bit slower into the part, which is G1, G90, and then Z. We're gonna decide where we want to pick up the part. So I decided to pick up at 1 inch and 600 is all the way on to the shoulder. So since we have inch per minute, we have to put a feed rate right here. And then we can like just go back to and then right here close the sub spindle collet, and then get ready for cutting. So we need to put the Q right here, 651, and over here also we have 2L651. All right, well, let me drink a little bit water. Okay, so after that, what next we're gonna do is we're gonna command the cutoff to come down. So right here, we can put the G50 back up in order to run it. W minus 0.625 right here, and then we can turn on the spindle. So remember, if you're gonna use G96, and then you have to like turn up the fluctuation, and then G50 S 3000, G96 S 900, and same thing over here. You're gonna need a M90 up, not M96, not M97, and then M94 over here too. Okay, and then you can do G1, G99, and you're gonna cut it down all the way to that with a feed rate wherever you want to put in there. And after I'm done with that, what I can do is I can just cancel the G600 right here. G600. So over here you need to put G600 also. Then you want to cancel the synchronization right here, G813. All right, and then right after this one, we want to check for the boot loader. So we're going to put M8, M8. So remember I said we need two M8. All right, and P for whatever the boot loader program. And then M9, to cancel it. All right, so right here we have a function, we call it the M50, that's used to check the cutoff to breaking. So we'll put it right there, to make sure it like stop, and then M3 S1 equal 100 right here. We turn it on, and then another thing is maybe put the dwell time in here, 5, and then we're gonna use M50. So right here, M50, if it see any movement in the subspindle, it will throw an alarm and say, hey, something wrong right here. And then it will stop the machine. And then we can open the collet and then go G0, X, no, not X, Z, whatever we have on top right here for the start position. We're gonna copy it right here. So I hope you can see this right here. I don't know. So this thing right here, you copy it and then going down, put it right here. All right. And then also you have to cancel the offset right here too. And then put the M56 to counterparts. And then that should be it. We're gonna finish it with M2, M99. But then like I said before, we're gonna need to put on the last part program function. So we're gonna go G999 and then N999 right here. Okay, the same thing on this side right here. We're gonna have G999 and then N999. Same thing. And then one more thing that I forgot right here, that we have to turn the fluctuation back on, which is right here. We can turn it right here, M97. Same thing over here, we can turn M95 right here. Okay, and then also right here, after we're done, we can put it back G97 also. On this side, we're also done, M99 right here. So what is for the last part program is going to be, it will repeat everything right here on the sub spindle, and then you're going to put inside the G999 and then N999 right here. But we have one function we're going to use is M98 in order to call the sub program. And then what I'm going to do is I will copy everything is right here. So copy everything right here, and I put down right here, I'm gonna call it N100, and put it down here. So on top of right here, you don't need to have too much code right here anymore, because it's gonna make your program as long as not looking like professional. So you can just delete this right here and then put in here M98H100. Okay, and remember, in order to get a loop back, you have to put M99 at the end of the program in order to loop back wherever it was before. So in the G999 right here, all we need to do is just give it like a mode in order to do, and then M99H100 right here. And after you're done, you're gonna like turn off the colon right here. So right here, and then also the M25, right? Okay, M25, this one also has to go into the subprogram too. All right, M25, M34. And then don't forget on $1, we have to put it G630 here, because if it's running to the last part program right here, it doesn't see G630 and it just sit right there and then doing nothing. So after that, we already done with the program, the complete program for the G630. But like I said, we're gonna do a little bit more with G660, and I hope you guys can stay a little bit longer so we can go over that. I think it's gonna be benefit for you to know more than one way to program the parts. So later on, if you get stuck, you need more station to use, you can use whatever you want to. So right here at the
So
beginning,
Han,
yes?
I think, it's almost 10 o'clock. I see some people dropping out, so it's probably getting late for some people. This has
Okay.
been 2 hours. So here's what I would suggest is that you will make the G660 program,
Okay.
and people can request. I gave them our email address, and people can request, and we'll send them both.
Oh, that's
However, I want to leave it up to the audience at this moment. Unmute your mics. If you can stay, Han can do it. If you guys would rather, I believe this is the right way to make this particular part. The only reason to go into G660 at this point would be if you're out of tools. Well, I need one more drill or one more spot, or I need to tap. Well, then you could start taking advantage of the dog leg because simply you're out of ID tool stations. G660 is not used that often, but it is a very powerful tool to use, and it does deserve some explanation, but we're running a little bit long in time. I'm going to leave it up to the audience. Continue, or we will send you a program when you email us at our email address. Unmute your mics and vote.
Continue. I actually have a copy of the program.
Okay,
So we got both. We got both of you. So you know what? If people have to leave, they can leave. Otherwise, then you can just continue. And so I would save this program, Han. Not of course, get rid of it, and then just do another program in G660.
Okay. Sounds
Cool.
good to me. All right.
Okay.
So if you need to leave and then leave and send us an email, we will send you a copy for the G660. But then if you can stay, and then I hope you can enjoy the class. Okay.
You want to
So
take a 5-minute break here real quick, Han? Are you okay?
maybe 5 minutes is going to be good because I'm being holding up. So.
Okay, so in the meantime, I'm going to show the class a few screenshots that I've prepared so they can see
Okay.
a few things, okay?
All right. Thank you, Mr. Zucker.
Okay, no problem. So hold on, everybody, and I am going to show you a few things and hopefully shed a little bit of light on a few things. Hopefully everybody can see my screens here in a moment. Bear with me. So I'm hoping everybody can see, it's a sample program A320N. I hope everybody can see that. Unmute your mic and respond.
I can see it.
Yes, we can see it.
Yes.
We can see it, Richard.
We're good.
Okay, so this is just elaborating a little bit more on, I know Han explained the chamfer corner rounding and the comma R and the comma C. So this is directly from the book from the A320. This kind of explains it a little bit more. The machine is capable of corner chamfer rounding or input of direct drawing dimension. So it's going to depend on this parameter value, what the machine is going to do. Normally, it's set for comma C, comma R, but if the program contains and does not contain this function, is invalid. But your newer machines are going to have this. So this is a simple way. If you're having, hey, it doesn't work, it's not working, go check this parameter and it'll tell you what's going on. But with that being said, in your book is some more examples of chamfer corner rounding that are pretty straightforward. I hope this sheds a little light on this and what they can do. The next example here, can everybody see my screen? I think I have to unshare and then reshare again because I'm sharing a different screen now.
Yes.
We can see it, Richard.
Bear with me 1 second. So hopefully everybody can see this shift.
Yes.
So I just wanted to elaborate on, we had a question earlier I heard about, the G50 shift for a boring barge, but just to elaborate how this value comes about. So this would be, basically the dog leg would be here. This is your boring bar, not sitting horizontally, but sitting vertically. And you can see the value in here. So they measured from center line to the cutting edge, 50 thousandths, and the G50U value is 100. We had a comment that people don't normally put them in geometry, let's say. So, is there a right way or is there a wrong way? Well, that debate can go on forever because it's really user preference. I see a lot of people do it this way. I see probably the vast majority of people doing it this way, but some people like to put the values in the preparation page. So it's just kind of user preference. My argument for that is if you put the G50 shift in the program, it travels with the program forever. It's always in there. Geometry you have to put in, and it could be an issue a little bit. But anyway, I hope this clears up anybody who's like, well, how do you come upon this number? And I'm pretty sure Han covered this already because this is from your manual that you guys have been looking at these last 3 days. And I just wanted to make sure that there was no cloudiness and where this number comes from the boring bar. Can everybody see this and everybody understand this?
Yes.
All right, I'm good now, Mr. Richard.
Okay, perfect timing. We just finished.
All right, cool.
Go ahead, continue.
Okay, so the next way we're gonna do
You
is
got to reshare your screen, Han.
Oh, okay. Sorry. Give me 1 second. All right, everybody see my screen now, right?
Yes.
Yes.
Okay. So we're gonna go a little bit faster than we did before. So what we're gonna do right here is we're gonna use G660 for the tour number 51 and 51 and 52. So nothing changed on the first side right here for the facing. We're still using G630, but right here, when we use the tour on the dog legs, we're gonna change it to G660 right here. So G660 over here, and then you also have to put G660 right here, because G660 or any G600 is working as a queuing code. If it doesn't see on the other side, it will alarm out. Okay, so we will go all the way to spot drill and drill done, and after that we will go back to G630 right here. And then same thing over here, you're gonna put G630 right here in order to do whatever it needs right here. So in the sub program right here, we also have to break it up in order to make it happen. So right here, we have the first tool is still using the G600 mode, so we can leave it alone in a N100. But the next next two tool, we have to put another block number right here. And then remember, we have to put M99 for the first block right there. And then right here, the drilling we done, we have to put M99 right here. And then we're going back here, we're gonna put N300 right here. So for all of this doing, now on the main program, what we can do right here, we can easily just call M98H200. And right here, and do M98H300. Okay, so everything now is become good. The machine ready to run, and we change the mode to G660. Nothing complain. But the thing is right here, for the last part program, is gonna change a little bit right here. Same thing on the main side right here, and on the sub side right here, it will change. If you want to keep the same way that you're doing on the top, and then you have to put right here G630, G630 over here, and then G660 right here, and then G660 over on the dollar side too, and you can call M98H200. But on this side, like I said, you have to call the tool parallel in G660 mode. It doesn't matter if you're going to use the tool or not. Even when you don't use the tool, you still have to call the tool. So right here, even when you don't use the tool, you have to put the T11 in here, and then also T12 in here. Right here. So the program is going to be a little bit complicated if you're using this way. But for me, as I said earlier, we have another G600 mode, and it's really powerful if you know how to use it. And it is G600. So you can use G600 for both sides. Right here. So in G600, it allows you to call all the tools that you've been doing in $1 and $2. So you just put right here in $2, and all you have to do is just command it M99, M98, M98, and then H100, H200, and 300. And everything is completed right here, gonna be done by the sub spindle. And then you don't have to call any tool over here in order to have it like parallel calling tool. But then one thing I want to say right here with G600 right here, when you call the tool in the back spindle, remember we're using the left hand cutoff tool. If you're using the left hand cutoff tool after cut up, that means that the material is still sticking out further or something. If you don't retract the material, when you call the T51 or T52 on the sub spindle, it will come over and it's gonna like smack on the material. So this way right here, I will put a waiting code right here for number 1, L, and then whatever the number you want to put, you put in here. Okay, 515, something like that. And then don't ask me why I put the L515 in there. It's just my son's birthday, so I remember the date, so I put it in there. You can put your son's birthday, okay? All right, so right here, I have to move the material in. So what I have to do right here, I move it 100,000 back, like away from the tool. So when you come with the tool on the T51, T52, it's not gonna crash on the material. But then, all right, one thing is gonna ease you right here. If you using you like push back the material on the main spindle, and then you don't put it back again for the start position, the machine, it will alarm when you run the last part programming. It say basically, okay, the start position, end position, it doesn't match. So one thing I will do right here is G50. I will put whatever the number they have before. Oopsie, not that number. All right, this number right here. So I will just reset the start position, and after I done with everything right here, I'm gonna have the 12 right here again. L556, 516. One L516. Oops, L516, like that. And then after we done on the sub spindle right here, we need to like extract this one out. We have to call the tool. So we have T00, and I have turned on the main spindle also. Okay, maybe 2500, and I will call it okay X.6 and Z. Okay, right here it's gonna be 630, and then T1. So I call the material out a little bit right here, and then I'm gonna phase it up. X minus 0.05 feed rate, 0.5. Okay, and then I will also open the collet right here, M7, then move it back to G0, Z, whatever the before right here, and then T0. So you have to do all of this thing when you use G660. Otherwise, you're gonna have the alarm for the start and end position is not matching. So we just add a little bit cutoff right here in order to put the machine back to the start position in order to end it. So right here, I could use M52 or 53. This one, delete over here. And then that's it. That's the whole program complete with the last part program also running for the G660. And the only thing that we mentioned already, well, only time when you need it is when you need extra tool station in order to put in G660, because with G660, you're gonna have to program it a little bit more than what you have to. Okay, so do we have any questions here? Need to lower the RPM to go to start position last time? No, we don't have to go to like loadout. You mean the RPM right here, correct? You can put any RPM.
Yeah, you're cutting off at, can you hear me? You're cutting off at 2,500 RPM, and then you open your collet and go to start position. You're still at 2,500. You're going to be at 2,500 RPM.
Oh, that's correct. Yes. Okay. We
Thanks.
have to stop the spindle. I'm sorry. Right here. We're going to have to stop the spindle. That's correct. Okay. All right. Any other questions right here?
So we have another question. Do we need to cancel the G50?
The G50. No, the G50 right here As you can see, I'm using the absolute value in order to tell the machine, okay, this is the position that you're going to start. It's just like a start position in the sub-program for the last part programming. So you don't have to cancel that G50. When you use the G50 with incremental, and then you need to cancel it. In this case, no, you don't have to. This G50 right here, I think the one that you talking about, right? All right, so is there any other questions? And remember one thing right here, okay? You're using the G600 for the last part programming because we don't want to use the G600 and then G660. That's going to take too much. And then G600, in this case, it will work better than G630. All right, any more questions? Okay, I don't see any more questions right here, so I think we can end this session here. And then I hope you guys enjoy the class and then send us back out your feedback. Either it's going to be negative or positive, anything like that. We will take it and then we try to improve and bring you more interesting class later on. And thank you.